So you've probably heard the word blockchain thrown around a ton, right? It sounds complicated, kind of technical. Well, today we're going to cut through all that noise. Forget the jargon. We are going to break this thing down with one really simple analogy: the community ledger.
But let's start with a big question. Think about it. What if our most important info, I'm talking money, property records, you name it, what if it didn't have to be controlled by one single person or one big company? That's the core problem that blockchain was invented to solve.
All right, to really get the solution, you first have to get the problem. So imagine a small town. In this town, every single time money changes hands, it gets written down in one giant book. And that one book is kept safe by one person, the town banker.
Now, what's the issue here? Well, the whole system is centralized. It all comes down to trusting that one banker. But what happens if that banker is a little dishonest and decides to, change a number? Or what if they just make an honest mistake? Or maybe their office gets robbed and the book is just gone. The entire town's financial history is super vulnerable. That's what we call a single point of failure. This slide just lays it out perfectly. On the left, you've got the old way, the centralized system. One person, one book. It's a single point of failure and, honestly, pretty easy to mess with. But then you look to the right. That's the decentralized system blockchain gives us. Lots of identical copies, no single person in charge, and it's incredibly hard to change anything.
So this is where our community ledger idea really comes to life. Instead of one banker with one book, the town decides to do something radical. They give every single person in town their own identical copy of the ledger, and it's updated for everyone at the same time.
Now, in this shared ledger, transactions aren't just written down one by one. That would be messy. Instead, they're bundled together onto what you can think of as a page. This page, filled with a list of all the latest transactions that everyone's agreed are valid, is called a block.
Okay, so once a page, a block, is full, the whole community checks it over to make sure everything looks right. When they all agree, that block gets sealed with a special, unique digital lock. This lock is called a hash. Just think of it like a high-tech, tamper-proof wax seal that proves the page is legit and hasn't been altered.
And now we get to the really clever part. It's not just about these sealed pages. It's about how they are all connected together to make an unbreakable chain. This is literally where the chain in blockchain comes from. This right here is the secret to blockchain security. That digital lock, the hash, on each new page, it's not made from scratch. It actually uses information from the lock of the page that came right before it. This creates a powerful link, making every single block dependent on the one that came before it.
So the process for adding new stuff to the ledger is always the same. First, new transactions are gathered up into a new block. Second, the whole community checks it, and once they agree, they seal it with its unique hash. And third, that new block gets officially attached to the end of the chain, securely linked to the one before it.
And this is why it's so ridiculously secure. Imagine somebody tries to go back and secretly change something on, say, page 5 of the ledger. The instant they do, the digital lock on page 5 shatters because the contents don't match the seal anymore. But here's the kicker. Because the lock on page 6 was built using info from page 5's original lock, the lock on page 6 breaks too. And then 7 breaks and 8 and so on. The entire chain from that point forward becomes invalid. It's a massive flashing red light that everyone sees immediately. Okay, so a broken chain sets off a huge alarm. But how does the network actually fix it? How does everyone agree on which version of the ledger is the right one? The answer is a cool process called consensus.
Just look at this. Imagine one person tampers with their copy, creating that one broken chain. When the network compares all the ledgers out there, you have that single, fraudulent version being compared against thousands upon thousands of correct, unbroken ones.
This whole comparison process is called consensus. Basically, all the computers running the network live by one simple rule. The longest, strongest chain, the one that the vast majority of people have, is the one and only official version. That one tampered copy, it sticks out like a sore thumb and is immediately rejected by everybody. It's powerless.
So what you end up with are two incredible benefits. First, the data is immutable. That's a fancy word that means once something is recorded and sealed on the chain, it's basically set in stone forever. And second, it's decentralized. There is no town banker. No single person is in control, which means we've completely eliminated that single point of failure we were worried about.
Now, when most people hear blockchain, their mind instantly jumps to Bitcoin and other cryptocurrencies. And that makes sense. It's a perfect use case for tracking money on a shared ledger. But
And this is a really big but. The real power of this technology goes way, way beyond just digital money.
I mean, think about any area where we need absolute trust and a permanent, unchangeable record. With supply chains, you could track a head of lettuce from the farm to your fridge, guaranteeing it's authentic. For digital identity, it could finally give you control over your own personal data. We're talking about sharing medical records securely between doctors, or even building voting systems that are completely transparent and impossible to tamper with. The possibilities are huge.
So, what's the big takeaway here? If you remember just one thing, let it be this. Blockchain is a decentralized digital ledger that fundamentally changes how we trust things. It lets us replace the need to trust a person or a company with the ability to trust transparent code and mathematics. It's a whole new way for us to agree on what's true.